All right, stats. Last week of the semester, we're going to look at some Chapter 9 topics. My throat is a kind of hoarse today, so I apologize if it sounds bad. So we're going to do 9.1 and 9.2. These are just abbreviated notes. Confidence intervals and significant tests for a difference between two proportions. So if you think about an experiment, right, typically there are two groups. There's a treatment group and a control group. And what we do is we observe how the treatment affects the one group, and we observe how the other group with the placebo works. And then we want to kind of compare them. And that's where this difference idea comes into play. Okay, so today is going to be focused on proportions. So we kind of have to go through the chapters again, going from chapter 6 through 7 through 8. Now, chapter 6 is very brief. It's just, exploring the sampling distribution. That's the whole normal distribution idea. So your shape is going to be approximately normal, right, for the difference between two sample portions if, and again, this is that large counts condition, right? If those conditions are met, notice there's two of them because you have two different samples. The mean is just going to be the difference in the population values, P1 minus P2. And the standard deviation is going to be this bigger square root. Again, before it would have just been one of these formulas or expressions, but now it's two added together because there's two samples. Okay, so again, with the formulas, this is not a huge deal. It just, double the work, I suppose. That's why, we'll do one problem together. You'll have one problem for homework. Very simple. Not trying to kill you this week. I know it's the last week. When you're checking the conditions for constructing a confidence interval for P1 minus P2, so again, the first condition is the random condition. Make sure that your two populations of interest are sampled, right? Remember, there's two groups. And then the large counts condition. And again, notice that there are two sets, and one p hat 1 and two p hat 2, and so on. And all of that has to be at least 10. Okay, when we're calculating a confidence interval, again, this is our formula for a C% confidence interval. So again, we just subtract the two sample proportions, add or subtract. So this is the point estimate. We add or subtract this margin of error, which is going to be our Z star. Z star, again, is the critical value that is associated with C% confidence level. So again, remember when we do these, here's your normal distribution. That C% is the area here. So that's your C%. And then again, it's the two tails that add up to the remaining percent. And remember, we always have to look for the left tail area. So if remember, we take 1 minus C and divide it by 2. Right? And that's how you find that left tail area. And that's going to get your negative Z star, but we always use the positive Z star when we do our calculations. And again, this is your standard error, the approximation for the standard deviation. And again, notice there's two things added because there's two proportions. And again, here's your inference method. It's a two sample Z interval for P1 minus P2. So that's what we'll write down for. We'll write that down in the plan step. Okay. Two samples Z interval for P1 minus P2. All right, excellent. Here we go. Okay. So example 1, how much did President Obama's approval ratings change? Many news organizations conduct polls asking adults in the United States if they approve of the job the president is doing. According to a Gallup poll, 1,500 randomly selected U.S. adults in October 2012, 780 approved of President Obama's job performance. A Gallup poll of 1,500 randomly selected U.S. adults in October 2014 showed that 615 approved of Obama's job performance. Construct and interpret a 90% confidence interval for the change in Obama's approval rating among all U.S. adults from October 2012 to October 2014. Let P1 minus P2 be the difference. October 2014 minus October 2012. So the first thing is, because you have two sets of data, understand that the ones are going to be the 2014 data. So that's going to be actually the second set of numbers. So that's this 1500, that's this 615. The twos are going to be the 2012 data, which is the first set. Again, 1500 and 780. All right. So notice I've done the state for you, and I will do that for the majority of these next sections. So we want to estimate P1 minus P2 at the 90% confidence level where P1 equals the true proportion of all U.S. adults who approved of President Obama's job performance in 2014, and P2 is the true proportion of all U.S. adults who approved of President Obama's job performance in 2012. Plan, we're doing a two-sample Z interval for P1 minus P2, and now here's where you come in. The conditions. First is the random condition. So I see 1,500 randomly selected U.S. adults in October 2012, and the same thing, 1,500 randomly selected U.S. adults in 2014. So I'll just kind of abbreviate that. So 1,500 randomly selected U.S. adults in October 2012 and 2014. Okay, and now we have to do the large counts condition. So before we do that, I need my value. So N1 is going to go with October 2014. That's going to be 1,500. And we'll do P hat 1. Let's do it. I don't know. We'll do it here. So P hat 1. That's going to be the 615 divided by the 1,500. And I'll just use a dinky calculator to do that. 615 divided by 1,500. And that's 0.41. So 0.41. So now let's do the large counts for these. So we'll do 1,500 times 0.41. That's 615. That is at least 10. And we'll do 1,500 times 1 minus 0.41. And that's 885. And that's at least 10. Okay, so far so good there. All right. And now we'll do N2. So that's still 1,500. And we'll do P. I'm going to run out of room. I'm going to try to squeeze it over here. Sorry. And we'll do P hat 2. P hat 2 will be the 780 divided by 1,500. So 780 divided by 1,500 is 0.52. So then we'll do the large counts condition for that. So we'll do 1,500 times 0.52. That's 780. That's at least 10. We'll do 1,500 times 1 minus 0.52. That's 720, which is at least 10. Good. So all of our conditions are met, so we can go ahead and do this problem. So here I come to do the problem. Okay, so now when we do the problem, so again, it's good to, revisit your numbers. So N1 is 1,500, and then P hat 1 was, I believe, 0.41. N2 was 1,500. And P hat 2 was 0.52. Okay, so now we need to find our Z star. So our left tail area is going to be 1 minus, your confidence level is 90%, 0.90 divided by 2. That's 0.10 divided by 2, which is 0.05. And now I'm going to go find my Z star on the stats applet. Okay, so let's go to the stats applet. Probability, normal distribution. So here's where you're trying to find a value, right? Your mean and standard deviation are always 0 and 1 for the standard normal curve. And my left tail area is 0.05. I calculate that value, negative 1.645. I take the positive 1.645. So again, within my do, so that's Z star, positive 1.645. Again, N1 is 1,500. P hat 1 was 0.41. N2 is 1,500. P hat 2 was 0.52. So now here comes our confidence interval. So we're going to do p hat 1, 0.41, minus p hat 2, 0.52, plus or minus z star. Now here comes your big square root. I don't know if I'm gonna have enough room. I hope so. So it's p hat 1 times 1 minus p hat 1 over n1 plus p hat 2 times 1 minus p hat 2 all over n2, and that's inside a square root. Okay, so I'll do this part, and then I'll do this part. So 0.41 minus 0.52, that's negative 0.11, plus or minus. And now let's go find our margin of error in the Desmos graphing calculator. Okay, so it was 1.645 times the square root of first fraction, 0.41, 1 minus 0.41, all over 1,500. Second fraction, 0.52 times 1 minus 0.52, all over 1,500. Again, your sample sizes aren't always the same. Ideally, they would be the same, but not always. So there we go. So right now, I'm going to take off this grid real fast. Give me a second so we can use this. Okay, good. So right now, we had negative 0.11 plus or minus, and we're going to round this. Let's go 0.03. That's fine. Okay, so that 9 makes the 2 become a 3. And now we're going to add and subtract those numbers. So let's subtract first. So negative 0.11 minus 0.03 is negative 0.14, and negative 0.11 plus 0.03. That's negative 0.08. So we have negative 0.41, negative 0.14 to negative 0.08, and that is our confidence interval. And now it's time to do our conclusion. Okay, and now let's write our conclusion. So I'm going to take that confidence interval back to our notes here. All right. So here's our conclusion. So we start off the same way. We are 90% confident that the interval from negative 0.14 to negative 0.08 captures the true, and we could put difference or change. So it doesn't really matter what you put. Again, this interval is the change, the true difference. And the proportion of all U.S. adults who approved of President Obama's job performance from October 2012 to October 2014. Okay, and again, they use the word change, I use the word difference. It doesn't matter, right? These are difference problems. But now we have to kind of interpret what these numbers mean. So we're going to say the interval suggests that President Obama's approval rating and then the negatives mean that from 2012 to 2014 it actually decreased, right? So we have to attach a word to this minus sign. Decreased by between, so by between by between 8 and 14% from October 2012 to October 2014. Okay, so again, make sure you have two sentences. One is more or less that way we interpret the confidence interval from chapter 7, I think section 1. And then here, the second part really dives into what those numbers really mean. Okay, so this was a confidence interval for a difference in proportion. The next video will be a significance test.